All right, we are good to go. So, questions so far. I got to make a few corrections on some character methods, but questions from you. Yeah, definitely we can go over accessing the linked lists in the hash map. Let me first talk about this isLetter business, because I think I threw some sort of pseudocode on paper yesterday, and I think I misspoke or miswrote. So we were talking about how to find out if a character in your word is a letter or not, right? And I said you can use the isLetter method. And I think I said, take your word dot character at I dot isLetter. But that's not right. So isLetter is not a method that we invoke using an object of type character. It's one of these statics, right? So here's our second mandatory use of a static. If we look in the character description for isLetter, it describes it as a static. isLetter is a method that takes an argument, which is a character, and returns a Boolean. So what I had mistakenly written was, so this is a no, word character at I dot isLetter. And that would work, right? This is a string, this is a character. If there was an instance method named isLetter, I could say, here's a character, tell me if it's a letter. But isLetter is a static method, so you call it like a C function, isLetter, parentheses, word.character at. So if you're getting issues with that, try it like that instead. All right. Let's look at accessing the linked list from the hash map. So let's suppose that our hash map, oh yes, character.isLetter. Yeah. Thank you. Right, so static methods, you have to specify the name of the class, period, and then the name of the method. That's how it finds it. Thank you. All right, so let's say you have a hash map, and it's a string, and the type of values are linked lists, and it's a linked list of integers. And let's say that your hash map is called index, so you construct it, with the same thing. Hash map string linked list integer paren. So I can say index dot get word, where word is a string, and this whole thing is now a linked list of integers. And so if I want to call the add method on that, I can say .add, and I can add a new node with an integer value n, for example, and that's all it's going to take, right? That's a hash map, that's the get method, that's the string, which is the type of key. This should be whatever the value is, which is a linked list. Linked lists have an add method, call that, and add the number n to the end of the linked list. So your pseudocode is something like this. If word is not in index, then put the word along with a new linked list. Angle bracket, integer, paren, right? So that you insert into your hash for the first time a key with the string of the word that you're trying to store and a value which is an empty linked list, right? And then you go ahead and you grab that linked list and add your new node to the end. So your add reference, if your word is already cleaned up, can be something like 2 lines of Java. One to create an empty linked list if the word's not already in the hash, and then the second line to grab the linked list associated with the word, add the position to the end of that list. Cool. All right, other questions, issues? All right, awesome. And I appreciate the cameras people have on. All right, so let's revisit something from 222 and somewhat from 224. Let's see. Wow, what am I doing, man? All right, so I got a pair of strings, S1 and S2, and I'm going to print out what S1 and S2 are equal to inside angle brackets so we can make sure there's no funny business going on at the ends. And then I'm going to say if they're equal, print out they're equal, otherwise not. That would have blown my whole demo, so thanks for catching that. All right, and hold on. Can you go over how the word count is offset by 1? So I think we're just calling the first word. Well, let me double check. Let me pull up the assignment. Constructor, process file. First occurrence is 0, second is 1, and so on. Let's see. Word count offset. So did I start the word count at 1? So this should occur at position 1. Yeah, so just when you're recording the position of each word in the file, just start counting from 1. So, you know, initialize your position counter to 1 if you're going to increment after you use it, or initialize it to 0 if you're going to increment before you initialize it. But we just do that so that you know, I don't know why. So that 1 means the first word instead of meaning the second word. Yeah, you're welcome. Yeah, VI, I only use about, 15 commands in VI, I think. And they're the same 15 commands I learned like 30 or 40 years ago. So I'm definitely not, like a VI power user. But, if you use the same 15 commands for 30 or 40 years, you get good with them. That's all that's going on. So this is why I suggest to people, instead of trying to learn, a lot of different commands and features and so on, just find a kernel that works for you and just stick with it and keep using it. And you'll get really good at it, right? Most of us are really good at walking because we've been walking our whole lives, and we always walk the same way. If you ride roller skates every day, you get really good on roller skates. You watch, a hockey player, and they're more stable on ice than some of us are, on pavement. It's just habit and repetition and pattern. Yeah. All right. So let's see if our strings are equal. So S1 is hello, S2 is a hello, S1 equals S2. So far, so good. Let's make S2 look like this. And S1 still equals S2. Okay, not too bad. Alright, so let's try this. And guess what? S1 and S2 are not equal anymore. So what's going on here? Why is hello equal to hello, but it's not equal to HELL plus O if I do that in two separate lines? This is a really good test question, by the way. Drum roll. Ta-da. Good thought, but yeah, when we print it out, it's still HELLO. HELLO. It's not a null terminator thing because we don't have null terminators in Java. But these are good thoughts. Yeah, so think about C. And there's something that I kept mentioning in C, and it was one of the harder bugs to find, which is when you have two strings in C, right, char star X and Y, and you wanted to know if they were the same, what did you do? You called the string compare method, right? Something very similar to that is going on here. So equal equal means, are these two things the same? Okay, S1 is an object, S2 is an object. S1 equal equal S2 means, are they the same object? right? And if I initialize both of them to be, you know, double quote HELLO, the JVM says, you know, okay, well, I'll make this object, this string containing these 5 letters, I'll make S1 equal to that, I'll make S2 equal to that also. And when I said, you know, HELL plus O on one line, the compiler was smart enough to say, oh, that's going to be the same as HELLO, I'll just make S2 the same object as S1. So in that case, they were exactly the same object. But here, S2 started its life as a different string, which means it was a different object. And then I concatenated an O to it, so that object has the words HELLO inside, the letters HELLO, but it's a different object. In C terms, they would be at different memory locations. We don't think about pointers in Java, but it's basically the same thing. It's a reference to a different object. And this, you know, will cost you a good part of the night. If you stumble into this at 3 a.m., it's going to be a long night and a lot of coffee. And good music, trying to figure out what's going on there. So, if we look at the string class, and if we look at most classes, there's a method called equals. And equals, we can actually pass it any other object. It doesn't have to just be a string. We can pass it any object and it will tell us if that string is equal to that object. And so equals is true only if the argument is not null and is a string object that represents the same sequence of characters as this object. And that's usually what we're thinking of when we say, you know, is this string equal to that thing? Are they the same sequence of characters, right? So we got to use a method to answer that question. So dot equals takes the place of string compare. So we can change our code here to use dot equals. So let's comment that out. So if S1 dot equals S2, and now they're equal even though they're different objects. So I don't think this will come up in PA2, but it will come up in PA3 and 4 and 5. So that's something to put on your radar. Let's see what I'm missing in chat here. So yes, exactly. Comparing the objects versus the character content. That's what equal does. Yeah, it does get harder as you get older, but still, there's something magic about, like, coding at 3 a.m. and coding until the sun comes up. That's actually always pretty fun. Was the compare line S1 dot equals S2? Yeah, so I put that up here. So S1 is a string. It has an equals method that takes, for us, a string as a second argument. That will compare character by character and tell us if they're the same or not. Can you also talk about how to properly add a new linked list to the hash map? Sure. So let's continue with, you know, your hash map called index. And so hash maps have a put method. So put will take a pair of arguments, a key and a value. So if we say index.put, and we've already looked, so word is not in the hash map. So we call our hash map's put method. We use a key value of word, and then the data value that we're going to associate with that can just be new linked list angle bracket integer paren. So that makes a linked list of integers and uses that as the value associated with this key, puts that pair into the index. Okay, yeah, cool. And again, you can do this in multiple steps. You could say, empty list equals new linked list, and then put empty list here. That would work too. And when you make a linked list, it's got to be an integer with an uppercase I, because this is expecting the name of a class. And lowercase I, int, is not a class, it's a primitive. It's one of those weird exceptions. Yeah, the angle brackets are a little interesting. So to add a number location, right, we don't want to do a put, because a put will replace the linked list that's already in there with this new linked list. But if the word is already in there, then we can say something like get the linked list associated with that word and call the add method. Right, so we would do this if the word is not in the list, and then we'd go ahead and we do this to add it. Let's see, so I'm still a little confused on what the next parts of the linked list will actually be. Like, is it the word count of that specific word? It's the location of that word. So the n that you're adding in here, right, is the location where you just found this word. So this is the add reference method. So let me pull this up again. So this is the add reference method, right? It takes a word and a location, and it creates an entry in the hash map. So your hash map looks like, here's a word, here's a linked list that has, a 5, a 7, and a 23. That means we found this word at locations 5, 7, and 23. Here's another word, it's got a linked list with a 7 in it, and just that one node. That means we found that word at location 7, but nowhere else. So there would be a counter when reading through the words to determine which word you're at in the sentence. Yes, so you have this local variable that I think I called position counter that you're just going to keep track of, initialize it to 0, and every time that you find a new word to add, increment this counter that tells you, what position you found that word in, pass that counter to add reference. All right, so this is basically pseudocode for the process file method. Prior to what? So this is inside your process file. So when you process a file, all this stuff happens, the file gets closed, and when you're done, you've got this index. And then you simply, so it pre-processes the file when you call process file, right? So you create your indexer, and that, like I said, doesn't really do anything. But then if you say index or ind.processFile, that does all of this stuff that we're talking about. Open the file, put things into the hash, and so on and so forth. So that has most of the programming, but like I say, you can really kind of get away with like 2 lines of Java in process file. because you're breaking out other things into pieces here, right? You're using your cleanup word and so on. Maybe 3 lines. Separate line to ingest the word and clean it up. So then things like this, number of words. So how do you tell how many words you have in your how many unique words you have in your file that you've processed? Position counter will tell you the total number of words, but how do you get the number of unique words? Yes, position counter does tell you how many words you ingested, which is useful. The amount of nodes in the linked list. So you have multiple linked lists. So if you want to know the total number of words, so you could make an iterator for the hash map and then iterate over it. But let's be super duper lazy. How many linked lists? Right. So how do you tell how many linked lists you have? Is there a method for hashmap to look at the count of keys? You know what? I'll bet you there is. Size, return the number of key value mappings in this map. Awesome. So you just say, you know, index.size, that tells you how many unique words you have. So your number of words method is 1 line. Just return index.size. Someone asked a few minutes ago, so the toString method, yeah, just return the hash map's toString. So return index.toString paren. How do you tell how many times a particular word appears in your input file? Count the nodes for that specified linked list. So how do we know how many nodes are in a linked list? How do we tell the length of the linked list? Yep, use the length method. And how do we find the length? Well, let's assume patterns. Let's look for size. Yep, size tells you the number of elements in the list. So how many times does word occur in our index, in our file, index.get word? That's a linked list. Call it size method. But be a little careful with that, because on the hash map, when we call the get method to get the value associated with a key, take a look at the details here. It returns null if the key is not found. So if I use this snippet of code to get the number of times a word appears, if that word is not found in there, this is going to be null. And I'm going to say, hey, call null's size method. I'm going to get a null exception. So this one I got to break into pieces. First I got to look at what this returns. And if it returns null, then I can say this word is contained 0 times in the file. If it's not null, then I can call the size method and say that's how many times that word is contained in the file. All right, so yeah, there's some more details on PA2, but you know, this is all good fun. How does the doc thing work? I wrote this a long time ago. So you can download the documentation online. So I pulled down this zip file and just, unzipped it. And then doc is just, guess what? It's a 224 bash script. So if I don't have any arguments, I just pull up the index of documentation. So I can just say doc, and it brings up sort of that first page. If I do have arguments, then I see if there's any slashes in there, and if there is, then I look for something in that particular area. Otherwise, oh, so if it's a 1, I didn't find it. So if I don't specify a slash, then I do a doc find, and doc find is another script that that basically searches for that given word.html. So if I look for scanner, I look for a file named scanner.html in this directory tree of documentation. If it doesn't find that, then I look for just scanner without a .html, and so I just look for a few different forms of this so that I don't have to worry about uppercase, lowercase, and so on and so forth. And the first thing that matches, getting increasingly flexible, I return. So I could toss this code up on the shared code area if you want to mess with it. I don't know if you can get it easily running in Windows, but if you have a Linux environment, and you can use like the find command, which is the main thing that I use in here. So find just, searches starting from this directory for anything with a name, ignoring case, that matches this pattern or that pattern, and so on. And it takes wildcards. And then this says go ahead and print it out. And Firefox is just Firefox because it's easy to run. And some other stuff in here where I get into weird stuff, multiple results. Yeah, okay, I'll pop that over into a doc area, and I'll copy this up there too, why not? It's only 93 meg. Yeah, mess around with it. Let us know if you get that working. Have you posted grades for PA1 yet? Yeah, I posted those over the weekend. Should be on Canvas along with comments and feedback. Well, it's possible that I forgot to hit the enter button, or that Canvas forgot that I hit the enter button. I will make a note and I'll double check after class. All right, let's see. Close that out. Let's talk about output. So we looked at using a scanner and a file constructor to do input from a file, which we needed for PA2. For PA3, we're also going to need to write out to a file. And so let's look at the output side. So, yeah, if I didn't get your repo, you would have gotten a 0, so that's not a problem. I'll double check Canvas and figure out what happened. hold on, I will, all right, there you go. All right, so let's look at output. So again, just like input, there's a lot of different ways you can do output. There's whole, cooked, uncooked, raw, so on and so forth. An easy way to do output, though, is to use a PrintWriter. So PrintWriters let us do things like what we do with system.out.println. So look at a PrintWriter. We can construct it with a file. So same as the way we constructed a scanner. So we can do a PrintWriter with a new file. And then if you look at the methods for a PrintWriter, there's print and there's println. There's also printf if you miss C and you want to do the %s, %d stuff, right? You can do a printf. But we can just do prints and printlns, the same thing that we've been doing with system.out. And we can do writes. We can do, like chapter 2 writes from the C runtime library if you want to do low level output operations and so on. So this all works pretty painlessly. So I'll create a new file named new file, and then I'll pass that to PrintWriter. Actually, I can just pass the name of the file directly to PrintWriter. I don't have to make a separate new file. So I can do that, and then let's go ahead and I don't know, let's print a table of squares. All right, so construct a PrintWriter. We'll go ahead and we'll print out, I times I equals I squared, table of multiplication table. We're going to have to do an import, so we'll import from Java IO PrintWriter. And this will work great, except it's going to want me to handle the possible exception when I try to do my construction. So look at the constructor where I pass a file name, and it'll throw a possible exception for file not found. If it doesn't, if it's not a writable file or a new file, it can't be created, or if there's a security manager present, blah blah blah. So we got to catch that error, right? So how do we do that? Make a try catch block. So if it succeeds, we'll just, save the value in PW. Now I could declare a catch block to catch specifically an exception of type file not found exception. And I could make another catch block to catch specifically an exception of type security exception. Or I can make a catch block for any larger scale exception. An exception is sort of the most general exception. So this will catch any exception of any type. And that's generally what we're going to use because, we're only kind of expecting one possible type of exception. So let's just go ahead and print an error message. And I'll go ahead and print E out so we can actually see what the message is. Let's see, so let me catch up on chat here. Yeah, I like having one repo also. I'm going to do that in 224 next year also. just have people do all their submissions in one repo, because then I end up with 1,000 repositories that I have to clean up after the year ends. You can import java.io.star, and that pulls everything in. It will slow things down a little bit. And if you just import, java.star, you're probably going to get into conflicts and stuff. So we usually make those imports pretty specific. But you'll see, asterisks in there sometimes. Can you catch both in the same try? Yeah, so I could have two catch statements going along with one try and specify different exceptions, or I can have, fewer catch blocks, and the first one that matches is the one that will fire. Alright, so this will almost work, but here's an error that you'll encounter sometimes. That's not what I meant. Here's an error you'll encounter sometimes. Variable PW might not have been initialized. And this happens a lot when we put in try statements around other pieces of code. And it's complaining right here, PW might not have been initialized. Well, why is that? Because, I try to give PW a value here, but if something goes wrong in constructing this PrintWriter, I'm going to kick out of this try block into this catch block. And in here, I don't give PW a value. So when I come down here, PW hasn't been initialized. And that's a really good compiler error. Because, if I don't actually succeed in constructing a PrintWriter, I do not want to try to call pw.println. That's going to give me an exception. So really, this is kind of pointing out to me the fact that, oh yeah, I should have, either exited at this point or tried a different file or something, but don't just seamlessly fall through and start trying to use the PrintWriter if you didn't construct it. When you specify different exceptions, I think you can use the same letter if you want. So I could have file not found exception E, I could have security manager E, I could have array out of bounds exception E, and so on and so forth. But it can also absolutely be any variable that you want. Alright, so that works fine. Alright, so that should compile, and now if I go ahead and I run this, it seems to have worked fine. Did it do anything? Hey, it created a new file.txt. Guess what though? That new file.txt is empty. Okay, so what happened there? Nice. I equals 0, I less than 10, I plus plus, pw.println. I'm telling it to print some stuff. Why didn't it print it? So go back to your PrintWriter, look at your methods. There's a method called close. Close the stream and release any system resources associated with it. Alright? We always want to make sure that we close our files when we're done with them. So at the end of my loop, let's call pw.close. Now I got some stuff in my new file. What's inside there? There's my table of squares. Alright, let's see. How does the try-catch know what exception it's looking for? It doesn't really. So you as the programmer need to know, that this could throw an exception. You need to look at the doc, see what exceptions could be occurring, and then write catch blocks for that. But when the system is running, if an exception occurs, it will start looking for any catch block with an argument whose exception type is either matches the exception or is, the technical term would be a superclass of the exception, so some more general exception. So if you get a file not found exception and it finds a catch block for file not found, it'll go ahead and execute the code in that. If it finds a catch block with a more general exception, it'll execute the catch block for that. So yeah, pw.close, it kind of like it saves the file, but really the way to think about it is when you write to a file, most of our I.O. is buffered. So so when we write to a file, it's kind of like there's this holding area. So the PrintWriter writes to here, and ultimately, you know, you've got your hard disk. So there's your drive A, right? Your good old floppy drive. Ultimately, what you write from the PrintWriter wants to go, you know, into some file, some sectors on your disk, but it's a long path to get there. You write into a buffer, and this basically saves up a bunch of stuff, and then when there's enough stuff in here, a big chunk of this gets dumped out. And it gets dumped out to, you know, we can imagine it gets dumped out to the actual physical disk. So if our program exits while there's stuff in this buffer, that stuff may not get written to the disk. Now when I close my PrintWriter, that will force the stuff to come out. But we can force it explicitly by calling a flush method. So if we call flush, that says take whatever's been buffered up and force that out to the drive, or whatever this device is. And in reality, there's a lot of other methods here, right? We don't actually write to the drive, we write to some kind of, you know, cache. And at some point that cache gets flushed out. But if this was, you know, if I open a file on a flash drive, right, and I write some stuff out and I say close and I exit my program, those bytes that I wrote may still not be on the flash drive, right? They may be hanging out in some kind of internal buffer that's part of the operating system. And if I pull my flash drive out, I might not see those bytes on there. So there's also this notion of flushing the cache. So when you do the safe eject, that's kind of like doing, you know, a close on the file, the buffer that's connected to your flash drive. So there's lots of hierarchies here, right? So yeah, you actually do have to eject sometimes. Unless your thing is set up for fast removal, in which case, in addition to writing into a cache, stuff is always written to the drive itself. So if you take an OS system, an operating system course, you learn all about these caching strategies and so on. Let's see. How do we specify between different catches? Yeah, so the catch business is strictly based on your catch statements. So if you have 3 catch statements with 3 different exceptions, then, you know, which one fires depends on what type of exception. So the exception is there, but it means it will keep going and see what happens. Yeah, pretty much. Yeah, you can still get into trouble though with flash drives. Like I say, on some systems you can set up a policy, and if it's set up for fast access, then there is a cache there, and you can actually still munge drives by popping them out. But it depends on your operating system and how your write policies are set up. All right, so we are good to go here. So so think about PrintWriters. That's basically all there is you need to know about PrintWriters, right? Construct them with a file name, print some stuff out with print line or print, close them when you're done. All right, so yeah, we can play more with exceptions tomorrow. We can look at multiple catch blocks and so on. And then I want to start playing with binary trees. And you'll be doing binary trees as part of PA3, and those you're going to have to cobble up yourself by hand, It's going to be a different kind of tree from a BST. So we'll start playing around with trees tomorrow. Alright, have a good one. I will see you next time.